Now we have all the information we need to assign quantum numbers to all the electrons in atoms. So we'll start with hydrogen, because hydrogen only has one electron. And if you look on the periodic table, you'll find hydrogen in the upper left corner, which is where we call the S block, and it's in the very first row of the S block. Remember, the S block starts at n is equal to 1, and it's S because we know the quantum number L is 0. So the location on the periodic table tells us, for that atom, where the last electron is going to go. What kind of subshell are we talking about? And we're talking about the 1s subshell, because that's the location where we find hydrogen on the periodic table. When we assign the electrons, we're going to first draw what's called the orbital diagram. And the orbital diagram shows a box as an orbital. And chemists are lazy, so instead of drawing the whole box, we're just going to draw the bottom of the box. We have one electron to put into that box, into that orbital, and that orbital is found in the 1s subshell. One S is what we call the subshell, and this subshell has one orbital in it, which is also called the 1s orbital. So it's a little bit confusing that the subshell name is the same as the orbital name, at least at this level, but that's okay. So we're going to put our first electron into this orbital, and the rule, remember, was the first one has to have a spin value of positive 1/2. And the way we show positive 1/2 is by an arrow pointing up to the top. So that is spin up. It's a positive 1/2 spin. So this would be the orbital diagram of the hydrogen atom. We have the 1s subshell, and we draw one orbital in that subshell, and we put in our first and only electron for hydrogen. We can also give the electron its spectroscopic notation, which has some of the information that the orbital diagram has. But instead of showing it in picture form, all we do is write the subshell, and the subshell was 1s, and then we write a superscript that is how many electrons do we find in that subshell. For hydrogen, there's only one electron, so the spectroscopic notation would be 1s with a superscript of 1. If we go to 2 electrons total, we'll have the helium atom, and look at your periodic table and you'll see helium is way over to the right in group number 18. However, that's not part of the P block. The P block starts at boron. So even though helium is written way over to the right on the periodic table, it's still part of that 1s subshell. So we're going to draw the orbital diagram. We have the 1s subshell, and we only have one orbital in that subshell. And we know the first electron for hydrogen was spin pointing up. The second electron has to go in spin pointing down. So the orbital diagram for helium would look like this. Spectroscopic notation, we write the name of the subshell 1s, and then we put a superscript of 2 because there are 2 electrons in that 1s subshell.